Okay. Open up.
So my quiz doesn't match the homework very much. So,
oh dear.
I know.
That's not a good.
I cannot understand any of that.
Okay, so we're ready to start the quiz. Off and running.
Yeah, I guess so. Oh my God. There are questions.
It's just the homework that we did. I didn't.
Don't worry, neither did I.
Well, I did the homework, but I'm noticing that I wrote down like A, B, C, D for my answers, but in the quiz, they're all mixed up. So it's like we'll really have to do it again.
Great.
Dang it. Oh, but you know what? Let me pull up the homework, and then I'll match up my answers to the homework answers.
Yeah.
And say out loud. I'll make that.
Okay, question number 2 on the quiz is the same as question 1 on the homework.
Let me get that open now. Okay, so for this one, I chose we are 90% confident that the true mean heart rate is between 45 and 105. Is that an answer?
That's what I got.
Yeah, that's what I got. That's B on the quiz.
Whoa.
Yeah.
B. They are mixing it up.
Exactly. So it's like that was A on the homework. So me putting A, B, C, D did nothing to help things, but
I know. Yeah.
okay. So for 2, let's see. For 2, I put yes, the distribution of the mean of each sample is normal since the data have been determined to be normal. But this is also one I had a big question mark next to. Like, I don't know if that's right or not.
I don't know either, but that's what I put also.
Okay.
Does anyone else have something different?
Okay, let's see. Question 3 is really 2.
Yes, I'm sorry.
And you guys got what?
I got yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yes, that's what I got too.
Perfect.
And wait, where's the quiz at? Okay.
Then number 4, it says of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? I put A, but I had a question about this one. So A is confidence interval for the mean differences using dependent samples.
And I put independent samples, but I'm not really good at telling the difference between dependent and independent. So
okay.
Wait, let me read the question again. Maybe I can see why I chose that. So what did it say? It said researchers decided to construct, see the difference. I chose independent because it didn't matter like which
I think
male
you're right.
or which like the correlation between the males and females
Right.
individually didn't matter.
They're just comparing the data. I agree with
Right.
that.
So that would be C on the test.
Yes.
In viewing that exam review, that is one of the ones she used as an example for independence, is men versus women.
Yeah. Okay, so 5, which is 4, could be. So for this one, I got obtain the balances of 90 bank customers rather than 30.
Me too.
Because when I went back and read my notes, it was saying when N gets bigger, the margin of, or what is it? I forgot now. Let me read the question. And not even. Smaller, yeah. When N gets bigger, the smaller the margin of error decreases. So if they have 90 versus 30, that's going to be a bigger N.
Got it.
So I put B, or it's B in here, but I don't know what it is on the quiz. Let's
D
see.
on the quiz.
D, okay.
So when N gets bigger, what?
When N increases, the margin of error decreases.
Decreases.
Number 6. Okay, what did I get for that one? Okay, on this one, I got 998.040 and 1001.960.
Oh,
For number 6,
Oh, wait, determine the margin of error. Okay, what's that one going to be on the other quiz? Oh, it didn't ask it.
that's right. This is margin of error, not the confidence.
Confidence interval, right. So this doesn't match at all, does it?
No. And this is the one I always get half right some of the time. In
Okay.
other words, 50% of the time I get this right, and then I don't understand why I don't.
isn't the margin of error the upper confidence interval minus the lower divided by 2?
Yes.
So this is the one sample t-test, right? Wait,
Hold on, let me read the question.
I did this earlier, but I can't remember now.
Sample mean to be. No, this is going to be that where they just give it. We're looking for the margin of error. So this is going to be the one that's M equals z-score times standard deviation over N.
Okay, I didn't do this one then.
M equals, okay, and so the z-score, they want 95% confidence interval, so that's going to be the z-score is going to be 1.960. And then let's see, times standard deviation is how much did they give that? 2 millimeters. So 2 over, and she selected 4, so the sample size is going to be the 4. Make sure I'm looking at the right thing here. Seems like super easy, and it seemed like it was not so easy when I was doing it before. Maybe I'm just getting better at it.
Oh, this is just the z-score one, right? This is where just the one sample.
Mm-hmm.
Yeah, so this one is easy. I like this margin of error. I don't like when it gets to the t-scores and stuff, because then I get confused.
Right.
This is the one that's difficult for me. I can't even remember how to do it.
Okay, so the formula is margin of error equals z-score, which correlates to the this is going to complicate it. It's z-score times standard deviation over the square root of n.
Yes.
But the z-score correlates to the confidence interval. So if they say like a 95% confidence interval, then the z-score for that is like 1.960. Those were the ones where they like gave us what the z-score was for the most commonly used ones. And you just plug in the right one. Two divided by 4. One. Okay, did you guys get 1.960?
Yeah. That seems really obvious or too simple.
Well, because it's going to end up being 2 millimeters is the standard deviation, and it's divided by the square root of 4, which is also 2. So 2 over 2 equals 1.
Yeah.
And then when you multiply that by 1.960, that's what you're going to get.
Yeah.
So I'm going to put that. Fingers crossed.
Yeah.
Okay. Okay, so when I put that information in, that's when it was it gave me the upper and lower bounds, right? That we had to answer on the test, the 998.040.
Yeah.
Because it's exactly the same numbers on the test. So it's going to be the same if I put it in again. So the lower bound is 998.040. And the upper bound is 1001.960.
Did you say 960 at the end?
Yeah. Yes, 1001.960.
Got it. So I have no idea what number we're on, except we're on number 9 on the test. How it's matching up.
040. Lower, upper, 101.960. Okay.
Oh, I found it. Question 9 on the test is number 6 on the homework.
6 on the homework.
Yes.
Oh,
And
this one was it took me a minute because I was like, oh, I can figure this out algebraically, and then I started to figure it out, and there was like a radical in the denominator, and I was like, oh my gosh, I have to go back. And then after all of that, trying to figure out how to eliminate radicals from the denominator, all this stuff, I realized we have a formula. We were given a formula, and you just plug the numbers in, and it was like done in 3 seconds. And I went, oh my gosh, it's hours on a wild goose chase. Oh man.
Well,
So
my answer was wrong. So whatever formula you have, please give out.
okay, here's the formula. It's this. I just called it the sample size formula. So this one is going to be n equals z-score times standard deviation over the margin of error, and then that whole thing squared. I'm going to try to. I'm going to write it really big on my paper and then try to share it with you guys real quick so you can see it.
Thank you.
Okay. N equals. Let's see. My little z-score has an asterisk on it because it's the one that you match up to the confidence interval. And I'm not very good at drawing these symbols. I apologize. I don't know if it'll be backwards either. Okay. Can you see it?
Yep,
Yeah.
it's not backwards. It's good.
Okay. So n will equal that z-score asterisk, like I said, you match that up to the confidence interval, times the standard deviation over m I put for margin of error, and then you square that whole thing. Everybody got it?
Yeah.
Yeah.
Okay.
She also goes over that in the review.
Oh, okay.
Review too.
So let me see. So in the question, they give us all that information that we need, even though when I started out, I was thinking, we don't have all the stuff we need for this.
That's what I was thinking, and I was like, I quit. I can't do this.
Yeah, because they were like, oh yeah, and we give it, it's like n times, and we didn't have this, you know, this is not known, and all this stuff. And I'm like, well, if we don't have anything, how are we supposed to figure it out? And that's when I started to get to going, oh wow, I can just do it algebraically, I guess. And then I went on a wild goose chase, and I looked back in my notes, and I was like, oh, it was right there the whole time.
Oh man.
Silly me. Anyway, so when I put all that in, I ended up getting, let's see, what is, you said it was number 6. I ended up getting 38,416. Did anybody else give it a try?
Yes. And actually, that's what I got to. Now that I'm doing this again, it is coming back to me a little bit.
Not coming back.
Because I recognize the equation. And actually, I remember doing a problem very similarly to this when we first started the class.
Yeah, after I did it, I realized we did like 4 or 5.
Yeah.
Between our homework quizzes and our group quizzes. We had 4 or 5 questions like this.
Yeah. Yeah, and I remember doing it now. But yeah, I got the 36,000. Oh, where did I put it? 36,416. Is that what you said you got?
No, I got 38,000.
38. I'm sorry. I reversed my 8 and my 6. 38,416. My bad.
Okay, number 10. Number 10 is another one that had a question mark next to, so I don't know if I have this right or not. Oh, wait, that's number, wait, what are we at? That's 10 on the homework. Let's see what's on the quiz. What's next on the quiz?
I'm horrible at these.
Okay, number 10 is which one on the homework? So number 10 is 7A. I put A on this one.
Which is
Hold on, which is not A on there. Which one is it? Hold on.
D.
Yeah, it's D.
okay.
I put D.
So we have the mean is less than.
Right, then 1250.
Gotcha. Okay.
Yeah, because he said he thinks that the apartments are smaller than advertised, so that would be smaller than 1250. So yeah, okay.
Gotcha.
On this one, I put if the p-value is less than alpha, because we say if the p-value is low, you reject the null.
Mm-hmm.
So.
And that's B. It actually matches the.
Oh yeah.
If the p-value is larger, we fail to reject the null, right?
Yes.
Correct.
Okay.
Oh, I think, we've actually done this question in one of our other, not with an ANOVA test, but.
Yeah, I remember this one too.
Right.
Like doing the apartment building sampling from, yeah, I remember that for GPAs.
Which I think is silly, but whatever.
Now, here's something interesting. I noticed on the homework, it said, maybe I'm misremembering it, but it said the sample, let me find the question on the homework. Yes, it said the sample standard deviations are nearly equal. And so I had to do some deductive reasoning on that one and go, okay, well, if the sample standard deviations are nearly equal, and that is just the square root of the, you know what I mean, of the, or this, yeah, the square root of the variance, because we on all of our stuff, it said we have to do the variance, right? The variance can be more than, so I was like, well, if those are equal, then probably the variances are equal, right? But then on this test, it doesn't say variances. I mean, it doesn't say standard deviation, it says variances. So, okay, we're clarified.
Bell shaped with no outliers and the sample variances are nearly equal. Yeah.
So if it's bell-shaped with no outliers, that's a normal distribution.
Yes.
So it's normal, and if the sample variables are nearly equal, then all the requirements are met.
So that is number C.
Yes.
Okay.
And I just went ahead and skipped
Letter C.
13 and 14.
Okay.
Because, specification is important.
Okay, so in this one, she ends up rejecting the null, even though it turned out that the null was correct. So when I went back and read in the homework, the description of a type 1 error was if you reject the null when it shouldn't have been rejected. So I'm thinking it's a type 1.
I do too.
Those stupid type 1 and type 2s, those are confusing too.
I cannot remember them. I mean, without looking, I can't remember them.
Right.
I can't get backwards.
Definitely going to have to put it on my cheat sheet that she lets us have, which is very nice, actually, because none of the other professors let me that.
And I like the reviews that she pinpointed. Put this on the cheat sheet. Put this on the cheat sheet. I thought, okay.
Oh, that's good.
Yeah, super nice. I felt like if I was able to have a cheat sheet in my calculus class, I would probably have an A in that class instead of the B I think I have. Yeah.
The level of significance alpha is made very small, making the probability of... Okay, so I think there was a converse relationship between type 1 and type 2, where if you increase your chances of type 1, you decrease type 2 and vice versa. Is that right? Or am I just remembering something crazy?
I know one goes down, one goes up.
Right, that's what I mean. So then that would be, okay, so that's two of us that remember that. So it's probably the case. So then that would be A. By reducing type 1, we increase type 2. Like reducing probability of 1 increases probability of 2.
Yes, I'm starting to remember this as well.
15.
I feel like I really glanced through that whole section of type 1 and type 2, and I'm not very good at remembering that.
Answer this test the hypothesis. Okay, let me match this one up and see what I got. So that would be 12. And on 12, I rejected the null. And I think I remember my level of significant, or my, what is it? Yeah, my p-value that I got was like 0.4 something, or 0.04 or something. So it was smaller than, right.
So we like the what is it called?
Reject the null.
Yeah, but the other one, not the null hypothesis, the
Alternate.
alternative. Yes.
Right.
So it's D on the test.
Yes.
Right.
I kept thinking adjacent, and I'm like, it's not adjacent, Kira. It's not.
Okay, you would like to look at the mean number of hours or by male and female. So we know it's not going to be a one sample because we have two things.
Yes, so it's probably going to be the independent.
Yeah.
Yeah, because they're not dependent on one another.
Yeah.
That's B for 16 then.
Yes. Okay, educate.
Those are dependent.
Okay, so yeah, I was going to say this was the one that was dependent. And the reason was if you pick the brother, you have to go with the same sister.
Yes.
Which would be D. Well, we don't know sigma, and we're not comparing the difference of anything because we're just doing one thing. So wouldn't it be A?
I think so.
Where sigma is unknown.
Yeah, because we don't have anything on here telling us what sigma is.
Okay.
That's good.
Yeah. We're more than halfway through.
Woohoo!
Oh, good. Another margin of error.
Okay.
Yeah, but this one's easier for me than the other one is.
Yeah. Even though we don't know sigma.
Oh, so this one, yeah, they gave us all the information. What did I get for this one? I don't even remember how we didn't do a margin of error on the homework for this.
I figured out the margin of errors are the little surprises on the quiz.
Mm-hmm. Which of the following?
Is this not the one where we minus the upper from the lower and divide by 2?
No, because this is still a one sample.
Yeah, and we still have a 95% confidence interval that we have to stick in there.
So what did they give us? Wait, maybe it is. Hold on, let me check for when sigma is unknown. What the... Wait, is this the one where you just put it in and it gives it to you?
That's what I did. But I want someone else to do it because I'm like 90% of the time never right.
Pulling up the
I got 2.025.
Enable editing. Let's put this in there. Copy. One sample t-test. Paste. Yeah, because it gives us the confidence interval.
Right.
7. Yeah, I think you're right. I think that's what we're supposed to do on this one.
I got one. Just kidding.
So 2.025, is that what you got after your rounding? .025. Is that what you got, Kristen? 2.025? Okay.
Yeah. And then my lower, I got 1.168.
Yep.
And my upper is 15.217.
Yeah, that's what I got too. Yay. 1.16.
1.15.217.
Yeah.
Okay. Sweet.
What was your upper bound one more time?
15.217.
Oh, good. Okay.
Let's see if that matches a test question. Hey, and that matches the test question answer too.
Yay.
So that's probably right. Most likely. Okay. For this one, I got confidence interval for difference of means using independent samples.
Crap, I'm going to get all those wrong. I chose dependent.
Yeah, so did I, but
I
dependent.
do. Let's go back and read that, what it said. Okay, do they depend on each other?
Well, they're not doing the exact same car and selling it in 2 cities, are they?
No.
So like the first Hummer, like on the list, isn't going to necessarily match what the second Hummer was, right?
Right. All the years are different. The mileages are different.
And you know what? For dependent matched pairs, you have to have the same number in each group.
Okay.
Right.
Okay.
So it's C.
Yeah, that's what I got. C.
So for 23, I got 40139.659.
40109.
139.
139.659.
659.
Wait, that's not what I got at all.
That's not good.
The lower bound. So 95% confidence interval for the true difference in the mean listing prices. For the lower bound, what did I get? What number is this? 18C. For the lower bound, I got -423. Oh wait, is that what you said?
No.
That's what I got.
Okay, what did I do wrong?
I think it's the difference because I did the problem for both the paired matches and the independent, and the independent comes up with these lower numbers.
So if you go for this one, since it's independent, you'll go to 2 sample t-test and put in the numbers.
Which numbers? Price and mileage?
No. There's price for New York and price for LA. It's another one of those ones where it's not broken out into different columns. It's all in the same
freaking
column.
Look at that, and I was like, okay, cool, one sample. Bogus. All right, give me a second. That's super lame.
So for the lower bound, I got negative 423.238.
And the upper would be 5417.34, correct?
Yes.
Okay.
Wait, I don't think we're supposed to. Are we still doing the 3 digits?
It doesn't say that, and on the homework, there were nothing past the right side of the decimal point. It was just negative 423.
I know, but that was weird because I ended up having to choose that because of the test, but because it wasn't an option. But I thought it was weird that she cut off the decimals when we're like, it's drilled into us to carry it out to 3 decimal places unless told otherwise.
Yeah.
Okay, tell me what you guys got again. Negative 721.131.
No, I got negative 423.238. You have to make sure you set all the parameters. So for this one, the confidence interval is 95%. So it's going to be 95% confidence interval. And then it says, let's see, we just want the difference. I don't think it matters what it is for the equals to or not equals to or whatever.
It doesn't, but that didn't change. I mean, my confidence level is already set. Hang on.
Oh yeah, it does say on the test though to round to 3 decimal places. 5417.336.
That's our upper bound, right?
Yeah.
0.336 for the upper bound on the end.
Yeah, 5417.336.
Okay. And look, 4 extra questions that were not on our homework.
Oh, I saw the bone density thing on the.
Okay, I quit. I can't figure it out. What's number 23? Sorry.
Oh, wait, I skipped a page. Never mind. We do have these. I got them.
Okay. Hey, Kristen, do you want to go over it step by step to see?
No, it's not the steps that's wrong. It's my copying and pasting of the stupid New York and LA horse crap.
Oh,
I'm so annoyed right now.
All right.
Because all of my information is correct, so I must be copying and pasting wrong. I don't know what else to do differently. Because now I have a negative 132 confidence interval.
You know what? Sometimes I'll have weird stuff go on like that when I've been using that quantitative or whatever it is, statistics thing. When I've been using it over and over for several ones, sometimes it will get hung up and I have to close it out and then go back in and like not save anything and then go back in and do it over again, because it has formulas and stuff in there, but sometimes when I'm changing stuff out, I'll accidentally delete part of the function as well.
Yeah.
Mhm. So maybe that. All right, so moving on, what number are we on now?
What was 23?
23 was negative 423.238.
Okay, and then 24?
5417.336.
Are we on 25 or did you guys do those ones already?
Nope, we're on 25.
Okay.
Okay, what did I get?
25 in ANOVA test because we have 3
Yeah.
different variables.
Yep.
So 25 is C.
Yes.
Okay.
For this one, the test statistic, I got 7.978.
Seven 7.798.
7.978.
Okay. I'm so tired. 7.978.
Yes. Yes.
We are in the home stretch, and I'm so ready for hot chocolate. I'm done.
I love it.
Yay, I got that too.
Yay. So then give us the p-value.
The p-value is 0.001.
And if you round, it's probably 0.002, right?
Correct.
Okay, good, because that's what I got. So which,
If it's less, we
if it's low, we reject the null,
reject
and
the null.
we say we have sufficient evidence to conclude. Okay, so there's 2 sufficient ones. This one, for the ANOVA, all we know is that one of them is different. One of the means is different. So that would be D.
Yeah.
But that's C in the
No, it's D on the test.
that there's sufficient evidence to conclude that the mean bone density of all 3 groups is about the same.
A, B, that's E, right?
Oh, yeah, no, it totally is. I didn't even see the first one. My bad. I was like, what are you talking about? It's totally C. My bad.
Yeah, I see what you mean. Like when I scroll down a little bit to where I can see all of them and the save button, I can't see the top one, and it looks like that's C.
Yeah, no, I totally missed it completely.
Okay. 20.
It's the last one, right?
We're close.
Yep, we have 4 left, 5 left. 1, 2, 3, 4, 5 left.
What
Okay.
I thought we just did 28.
Oh, we did. I just haven't hit save, so we have 4 left. Just kidding.
Okay. I was saying, what? Not showing up.
Okay, this is the one that hangs me up on the dependent and independent one. So we're comparing two things. So we know it's either going to be the dependent samples or the independent samples. But I think this one is dependent because they're going to compare the cost for that specific plane ticket, right?
Yes, and I think I wrote it down just barely today when she was going over it.
Yeah. Let's see.
Two distinct groups, like male versus female or Utah versus Colorado. And it's generally like versus. And then the dependent ones are like pre and post test, right hand versus left hand.
Husband and wife.
Test, those are hands. So these are tickets all for, I think
Right.
this
I think it's dependent. I'm leaning towards dependent on this one because it seems like they would, if you know the price of a specific ticket 14 days out versus 90 days out, it would still be the same ticket. So I think it's dependent.
Well, and it's like for the same flights in advance, right?
But
Yeah.
then this one always messes me up too because I think when I looked on the Excel sheet, do I still have that one even pulled up? Oh, thank goodness I do.
Awesome.
But then when I pull up the Excel sheet, it's like, oh, are they not the exact same flights?
Oh, I thought they were the exact
They
same.
are.
they?
They're
Are
just
they?
different days.
Then it
One's
is
at 14 days, one's at 90 days.
Okay. All right. So it
dependent.
Dependent.
dependent. Okay.
So is that the paired whatever?
Yes, that's the same as the paired sample.
Okay.
All right, 30.
So the test statistic I got was 1.685.
Let's see if I even have that one still.
I hope that that's right.
285?
1.685.
Oh, 685.
That is also what I got.
Fantastic.
Yay.
And
Very
the
good.
p-value I got is 0.095.
That is also what I got. Actually, I got 0.096.
Yeah, I got to round up.
Yeah, if I rounded, I would have got the same. The following best expresses the conclusion of this test.
Okay, so our level of significance on this one is 0.1.
1, and our p-value is 0.09, so it's less.
So we reject the null.
Null.
And that means sufficient evidence.
To conclude that there is a difference.
Yeah.
That would be B then.
B for boy. Yep.
That's what I got.
All right.
The last one.
See how we did. Make sure I saved everything.
Ooh.
Not
Well,
good?
We got a 93. No, sorry, it is good. Whoa. Like awesome hair.
What did we miss?
So we missed. Oh my gosh, where is it? We missed number 26.
I got 100, Kristen.
I did too.
So did I.
So you must have typed one in wrong. You missed 26, you said?
Yeah, I put 7.987.
Yeah, you got them backwards. It's 7.978.
Perfect. And then number 28
was
D.
Number D. Number D. I did it again. Letter D.
I put E. I think that's all I got wrong. So
Well, make sure you write the answers down so when you take the test over again, you just have to change those two.
Yeah.
Yeah, exactly. All right. Good luck, ladies.
All right. Good night, everybody.
Night. See you next week.
Gonna go and study all those margin of error stuff. Oh my gosh. All right, here we go.
All right.
guys.
Bye, guys.
Bye, guys.